Hi 6th graders, today we're going to be taking a look at sample spaces. By the end of this lesson you want to be able to construct sample spaces using tree diagrams or by making lists. First of all, what exactly is a sample space? A sample space is the set of all possible outcomes. One way we can do this is by something called the fundamental counting principle, and we've actually talked about this a little bit already this year, but now we're giving it a name. This states that there are m outcomes for the first choice and n outcomes for the second choice, and the total number of possible outcomes can be found by taking m times n. So let's look at an example of this. In my closet I have green shorts and black pants. I also have a white t-shirt and a yellow tank top. I want to know what are all the different outfits I can make with the black pants. So if I have to use black pants, I really only have one option for my pants, but I have two options for my shirt because I have the white t-shirt and the yellow tank top. So my total number of outfits is 1 times 2, or 2 different outfits. But how many outfits could I make in all? Well, if I look at all of my possible clothes, because I have green shorts and black pants, there's 2 different pant styles I could wear, and the 2 different shirts, so 2 times 2, or 4 different outfits I could make in all. Besides the fundamental counting principle, which can tell us the total number of outcomes, we sometimes use a tree diagram which will show all possible outcomes of an event. For example, at a restaurant you can choose either crispy or grilled chicken. Then you can also choose ranch, barbecue, or plain. So we want to know how many different combinations are there. So we can use a tree diagram. So it looks something like this. So my first choice is the type of chicken. I can either use grilled or crispy chicken. Now, if I pick grilled, my tree grows from there because I have 3 more choices. I could choose ranch, barbecue, or just plain. Same with the crispy. I could do ranch, barbecue, or plain. Now if I look at the end of my tree, so these, I can count 1, 2, 3, 4, 5, 6. So there's 6 different combinations. And if we needed to list them out, this would help us organize our list, because I could do a grilled ranch, grilled barbecue, or a plain grilled. I could do a crispy ranch, crispy barbecue, or a plain crispy. By the same thing, if we were just looking for the number of outcomes, I could use the fundamental counting principle. There's 2 choices for the type of chicken, 3 choices for how it's prepared. 2 times 3 gives us 6 combinations. Now I want you to pause the video, and I want you to make a tree diagram to show the sample space of how many ways you can order an ice cream cone. If you have a choice of a sugar or waffle cone with the choice of chocolate, mint, or vanilla ice cream. And then you can also try the one on the bottom. Alright, so hopefully you started out with first your cone choice, so you could do sugar or waffle. Then if I do sugar, I can do chocolate, mint, or vanilla, waffle chocolate, waffle mint, or waffle vanilla. So once again, I have 6 combos that I could make. What about at the Pizza House? They offer a choice of hand-tossed thick or thin crust, and their possible toppings are green pepper, ham, mushroom, onion, pepperoni, and sugar and sausage. I want to know how many different one-topping pizzas I could order from Mama's Pizza House. Now I could make a tree diagram, which means my first choice would be either hand-tossed, thick crust, or thin crust. And then I have green pepper, ham, mushroom, onion, pepperoni, and sausage. As you can see, the tree diagrams can get a little tough, especially in this limited space that I have on this sheet. So another thing that we could do is the fundamental counting, because they're just asking how many different one-topping pizzas I could order. So if I have 3 choices for my crust, and then my topping choices are 1, 2, 3, 4, 5, and 6. I have 3 times 6, which would give us 18 different one-topping pizzas I could order from Mama's Pizza House. Don't forget to ask a question on Edmodo, and we will talk more about this tomorrow.